Here we have a demand equation, and we want to work with finding the whole elasticity of demand equation. So we are going to start by plugging in to what E of P is. First piece of the formula, I like to put the negative right with the top there, negative P, and then we take a derivative. Since this is an application of derivatives, that makes sense. So derivative of 15 is 0. Derivative of negative 5/6P is going to be negative 5/6 over the original equation, original F of P, which is 15 minus 5/6P. This might be one where you could pause it and see if you could simplify complex fractions on your own, or maybe even do the next part, see how much you can do after watching a couple videos on this. So we have a negative P times negative 5/6. A negative times a negative is going to make it a positive 5/6P over 15 minus 5/6P. I need to get rid of complex fractions. So I have a denominator in my numerator. That denominator is 6. So that gives me the number to multiply everything by to get rid of complex fractions. That's 6 in the top and 6 in the bottom. Should not be there. So in the top we have 6 and 6 cancel, so we're left with 5P. In the denominator, we need to remember to multiply these numbers together. So we're going to have 6 times 15, which you could use your calculator for. You're going to get 90. Over these 6's cancel, we're just left with a minus 5P. Here is our elasticity of demand formula. We can plug in any price to this and see the type of demand that we're going to have at that price point. So the next part is just plugging in and seeing the type of demand if we set the price to be $6. So that means I'm going to take that $6 and plug it in for P in the formula above. So I'm going to do E of 6 would be 5 times 6, which is 30. In the bottom we have 90 minus 5 times 6. We have 90 minus 30 is 60. You could reduce this or make it a decimal if it helps you figure out if it's bigger than, equal to, or less than 1. It does reduce to be 1/2 or 0.5, however you wish to write it. It is less than 1, which means we have something that is inelastic here. Inelastic means we could change the price and there should only be a small change in demand. The last part says, well, what price would we have to set it at to make the demand unitary? So for what P is the demand unitary? So unitary is this second case here where E of P has to equal 1. So we want to look at this formula from part A and set it equal to 1 and solve. You can definitely pause the video and see if you can solve this yourself. We're going to make E of P equal to 1. So unitary, just to give ourselves that mental cue, that means setting E of P equal to 1 when you see the word unitary. So I'm going to set 5P over 90 minus 5P equal to 1 and solve for what price that would have to be. So first of all, you want to solve for P, but it's stuck in the denominator. So we're going to multiply both sides by the denominator, 90 minus 5P. On the left, we're just left with our numerator. And on the right, we have 1 times our denominator. 1 times anything is just going to stay itself. So again, we end up with the numerator equals the denominator. And now I want to get P by itself. So I'm going to put P's all on one side. So in this case, I'm going to add 5P over. So I get 5P plus 5P, I get 10P. Equals 90. And then lastly, what do I have to do to get P by itself? It's multiplied by 10, so I'm going to divide both sides by 10. If I get a decimal, I want to round to the second decimal place because it is money, but 90 divided by 10 just means the price should be $9. You don't have to check these answers, but just for good measure, I want to make sure I got it right before making any recommendations to a company or something like that. So I'm going to check it by plugging into the original equation at the top here. This 5P over 90 minus 5p. If I plug in $9, I should get 1 out so that it's unitary. So I'm going to do that here. I'm going to do 5 times 9. 5 times 9, which is going to give me 45 on top, over 90 minus 5 times 9, which is going to be over 45. It really does equal 1. So we definitely got it right. We plug into part A the price we got, and we really do get $1, or equals 1 out. So we know that we want to make the price $9 in order for the demand to be unitary.